Please welcome Vice President, Amazon EC2 AWS, Dave Brown.
Well, good morning, everyone, and welcome to the reInvent 2022 networking keynote. One of my favorite keynotes to give because we've made so much progress in networking over the last 15 years in AWS. I actually joined the Amazon EC2 team 15 years ago. It was a small team of just 14 people. I was the 15th person to join. Back then, we had a very, very simple network. We had our classic network, which really didn't have any of the networking functionality that I'm sure many of you enjoy today. Now, I understand some of you might be network administrators that just stepped away from your CLI console and looking to get back to that and desperately hoping we have that interface at some point. And some of you might be developers that feel, why do I have to worry about all this networking in the cloud? I didn't have to do that at some point. Well, I want to tell you today that we're going to cater to both of those personas, and I think we've done a much better job over the years in making sure that network administrators can manage networks and developers can build without having to worry about the complexities that networks sometimes introduce. But with that, let's get going. There's been one ambition that's driven us in networking over the years, and that's actually to provide you, our customer, with tools and services to build scalable networks for any workload and promote an increased pace of innovation. I didn't come from a networking background. When I joined EC2, I was a distributed Java developer, actually, and I learned about networking over the years as I've led many of the networking teams. And that pace of innovation is something that networking hasn't really been thought of. Most of us, from a developer point of view, we don't think about the network until we need to open a firewall rule at some point and go and meet with the networking team to say, hey, we actually need, and they say, what do you want to do? And we have that discussion. And in the cloud, I think we've made a little bit more progress in bringing those two personas together. One of the customers that we had the privilege of working with over the last couple of years has been Dish Wireless. Now, you all know Dish as the satellite TV provider, but about 4 years ago, well, end of 2019, Dish came to us and said, we'd like to build a 5G network, and we want to do it on AWS. Initially, I thought they were crazy, and we started to look at what it might mean. And actually, just earlier this year, Dish launched their 5G network, first 5G network ever running in the cloud. And it actually runs from all their cell towers, uses our local zones, uses the AWS backbone to our regions, and actually covers more than 25% of the US population today. So just an incredible story of what we're able to do at scale for a customer like Dish. We've got a lot to get through today. We're going to talk a little bit about our global scale. In last year's keynote, I spoke a bit about our data center infrastructure. This year, I want to broaden that a little bit and talk about our backbone. We'll look at some of our performance, how we're making progress on instance networking. Then we'll look at some of our large-scale networking topologies. This is where we're getting to VPC and transit gateway and those sorts of services. Networking for applications. Can we simplify networking? Can we bring it up? And keep a lookout for some new announcements in this area. Industry-leading security, obviously super important for us, always number one thing we're thinking about. And then building networks at a global scale. What can we do to help you, even outside of our regions, to manage your network? So, got a lot to get through. Let's get going. Start with our backbone. That is a map of the world, and these are our regions. We actually just launched our 30th new region in Hyderabad, India, just about a week ago, less than a week ago. And we actually have 5 new regions coming. We have 1 more region before the end of the year. I'll keep you guessing as to which orange dot that will be. You can overlay our local zones. Local zones are relatively new. We launched our first one in 2019. The idea of this is really a networking problem. Customers have said, I'm too far away from a region. I need a local zone. And so we launched our first one in Los Angeles for the media and entertainment space. And think of that as we just built an availability zone, and we just stretched the networking cable down to Los Angeles from Portland. And so a customer in Los Angeles is getting 1 to 2 milliseconds of latency. The latency back to the region is about 10 milliseconds, but they need that low latency for GPUs and online editing of video footage and that when they're doing media and entertainment. So we now have 25 local zones. We have 27 coming soon as well. We just launched 4 in the last week. You're going to see us blanket the world, and you can see all the green dots as to where they're going to be. Edge locations, CloudFront, providing a CDN to our end customer and making sure that no matter where you are in the world, you can get access to the AWS backbone and super low latencies. We have 440, more than 440 CloudFront locations now around the world. We also have 115 direct connect locations. You can think of those as MPLS-like connections directly into the AWS cloud, dedicated to you, dedicated fiber as well. Put it all on one map, and it starts to look pretty impressive. What looks more impressive, though, is when you overlay our global backbone. We started building this back when AWS started. Super interesting journey. We realized that we needed to have dedicated network infrastructure that literally blankets the world to make sure that the traffic that we carry for our customers can get from point A to point B without having to worry about all the ISPs along the way actually highly available. And so this is what we have today. It's all redundant 400 gigabit links. We have 245 countries and territories that are covered. And all traffic between our regions, local zones, CloudFront edge locations, direct connect, whatever it might be, was all encrypted and carried on that AWS backbone. Now the question is, why do we need a backbone? And I want to go into some of those details and why do we build this. First one is scalability. We'll dive into that a little bit, and let's take a look at that. You know, what customers are looking for, most of you are looking to run an application in the cloud. And typically, you're not actually thinking about the global backbone. The only time you start to think about the global backbone is when it doesn't do its job. And you know, we could not be a cloud provider without a backbone that can carry the scale of traffic that you need to carry and all our customers need to carry without operating absolutely flawlessly between regions. And actually, for the longest period of time, we didn't even talk about our global backbone. We didn't even think about it being something that customers needed to know about until some other folks in the cloud started talking about their global backbone, and we were like, hey, hang on, we have one too. And we've obviously scaled this tremendously. So we started that global backbone. So what are some of the challenges, and what do we have to think about as we scale the global backbone? The first one is planning. You can imagine running a piece of optical fiber across the Atlantic. It takes a little bit of time. We have to get a ship out there, we have to put the cable behind the boat, we have to travel the distance, a lot of complexity that goes into doing that. And one of the things we have to think about is how large is AWS going to be in 5 to 10 years' time? How much capacity are we going to need on our global backbone to be able to carry the traffic that customers are looking for in 5 to 10 years' time? The other thing we have to think about is there's probably not enough backbone capacity, dark fiber capacity in the world for us in 5 to 10 years' time if we continue to grow in the way that we've been growing. And so this team is continuously planning, continuously looking to actually put fiber in place. Sorry, can we just go back to the previous slide? The second one is cost. And so we have to think about, you know, putting this fiber in place is obviously a large CapEx investment as well. And we're obviously doing that and making sure that we optimize. You know, we want to have the scale ready for you, but we only want to have it just in time as well from a cost point of view. Supply chain, you've all heard a little bit about supply chain. I think we've all learned more about a supply chain than we ever wanted to learn in the last 2.5 years. Well, we're going to make sure that everything from routers to the various optical fiber pieces, everything that we need at scale is available to us and we're not slowed down in this. And then there's obviously the physical work. At some point, we need to put a fiber in the sea, we need to dig a hole, we need to dig a trench, we have to make arrangements with local municipalities and governments and sidewalks to get these fibers where they need to be. And so, in the last couple of years, you can see some of the actual lines that we've been involved in putting in place that are across the seas. We had one that followed from the east coast of Asia over to the west coast of the US, and then we've actually done 2 across the Atlantic as well. And this is all making sure that we have enough backbone capacity to support your workloads for the coming years. And we're certainly not slowing down there. There's many more in place as well. The other thing we have to think about is what is the software and the hardware that we're actually using to run our backbone. And as you saw, if you watched my talk from last year, our network routers that we use in our data centers, they're actually custom designed by AWS for our own data centers. And everything is designed ourselves. The software that we use, we strip out. We don't have a lot of the features you get from a typical router. We take it down to the absolute smallest footprint of software that we need. That helps us ensure high availability, keep it simple. We're able to debug if there are issues. We've done the same thing on our backbone as well. We actually have custom hardware for that. One of the things we've actually been able to do is to use the same switches that we build for our data centers in our backbone, which actually puts us as one of the largest switch manufacturers in the world today, even though we deploy it only on AWS, just given our incredible scale. And our typical switch today looks like this. It's able to carry 12.8 terabits per second. It's a single device. You can see it's got 32 400 gigabit ports. It's not an actual picture of the switch. It's just one we drew in PowerPoint. But it's custom designed, everything from the silicon up, and all the software on that as well. When we deploy these and we think about transit sites, we actually deploy them in groups. So we can take 42 in a single rack. They're all 1U switches, so 42U rack, filled with switches, and that actually gives us 100 terabits of capacity at a single rack level. And if you think about a transit location, we would actually deploy up to 32 racks in a transit location, which means at one transit location, we can carry 3,200 terabits per second. Now, for those of you that aren't into networking, I'm not going to make you raise a hand at the networking keynote. That is approximately 20,000 copies of the entire English language Wikipedia every second of capacity that we're able to carry through a single transit center. So the scale is pretty impressive. Next, I want to talk a little bit about availability. Obviously critical. As I said, we have to operate absolutely flawlessly. Now, one of the things we've learned in AWS, and it's become a common saying, is we have to expect everything to fail all the time. It's something that Werner Vogels has said many times. And it's not that everything fails all the time. Hopefully that's not the impression I'm leaving you with. But it's that we have to expect everything to fail all the time. So we can't put anything in place without saying, when that thing fails, what happens? How do we mitigate that impact? And I'll show you a few failures. These are always fun to look at. Every time we have a fiber cut, we get a photograph. And the teams are, in the ticket that's tracking the fiber cut, it's like, well, what had happened here? What did it look like? There's some very interesting ones. This one here was actually in the US somewhere, and somebody decided to drill a hole through the piece of conduit that was carrying our fiber. And that obviously takes a couple of hours to be fixed. We obviously have a conversation with the construction company that decided to drill a hole. We've had a couple of interesting ones in China as well. These things in the middle there called diggers are every fiber owner's worst nightmare. They are constantly finding fibers and eating them. And in this case, somebody decided to shove some metal plates through a piece of optical fiber that they couldn't see. We also had some problems at the bottom of that manhole cover over there. I'm not exactly sure what happened, but it was clearly an event. So one of the things we have to think about is at any point in time, a piece of optical fiber on the Amazon backbone could be cut and could be impacted. And you've got to think about redundancy in a different way. You could have a given data center with two pieces of optical fiber coming on outside of the building. And we track that. You can see those little gray dots are actually GPS coordinates that we get given from either we put the fiber in place, or if you're using dark fiber that's available, we will have a GPS coordinate every meter of where that fiber actually was. The problem is sometimes the fiber does this. There is only one bridge or only one footbridge or something, and these two pieces of fiber wrap around the building, and on the other side they are within 1 meter of each other. That is obviously a problem. Remember the digger? It comes along, it eats up both pieces of optical fiber, and that data center is not available. And that's a worst case scenario for us. So what we actually do is we track all the GPS locations of every single piece of optical fiber, and we have systems that are constantly making sure that we never ever have situations where fiber actually converges and puts us at risk. We also don't trust the GPS coordinates, by the way. We've learned this the hard way. And so what we do is we actually are able to put light through the piece of optical fiber, which allows us to actually measure changes in direction of the cable, and we're able to build a model to actually prove whether the GPS coordinates are correct or not. And so that's something else we do to just validate. Some of the challenges here, obviously we have to monitor. We consume billions of metrics every single second on every single fiber within the network to make sure it's operating just as it should be. That's not just is it up or is it down. That could be things like heat or monitoring on the various optical sensors to see, do we think there's going to be a problem, should we proactively shift traffic. Obviously detection is all fully automated, any defects, and we can mitigate those faults as well and fail away. We also have to worry about the internet. Things outside of the AWS backbone can sometimes affect us. Sometimes it affects you. Sometimes it affects a very small part of your customer base in some country where there's some sort of internet weather causing problems. We take ownership in actually working out how do we route around that, and I have your customers route off in a different direction. And then we want all of this to actually be self-healing. We want to make sure that traffic is routed, the decision is automated, and traffic will be routed around any sort of break. One of my favorite stories, and this happened about 3 years ago, was actually in our Virginia region. Any idea what caused this? It was a digger, okay? It got through a piece of optical fiber, and the incredible thing about this story is not that it happened. The incredible thing is we only dropped 13 packets. And the reason we dropped 13 packets is we've moved a lot of our failover and mitigation away from changing BGP and changing routes. We've actually moved it to optical failover. And so we're actually able to find another piece of redundant fiber and literally just switch the light as soon as we see the impact. And so we can get down to this sort of impact now. There's no convergence time. It's immediate. We just lose a few packets of, a few pieces of light. Next, I want to talk a little bit about performance on the backbone. And obviously, our global backbone, we spoke about the 400 gigabits of capacity. And obviously, we've gone through 100 gigabits. We're now at 400 gigabits. And one of the things we've been innovating in is actually how many strands of fiber can we actually put in a piece of conduit. And obviously, it's really just a density problem. If you can pack in more strands, you can get that fiber to be a lot thinner, or you can actually send more data through that. You have more circuits available. So we'll start up on the top right, 1,728 strands. That's what we started with. Then we got to 3,456 strands. I like that one because I can always remember the number. Then you get to 6,912 strands. That's our current most dense piece of fiber that we are deploying. Guaranteed that you can see they're all about the same thickness and same size. We can just carry a lot more capacity. The one on the far left is actually 1,728 strands, but it has a termite sheath. We only deploy this fiber in Australia. And then finally, we get down to security. The first thing we have is encryption. Any piece of data that you send in EC2 is actually encrypted multiple times. If you send with any one of our Nitro-based instances, anything from like a C5N or newer, it's actually being encrypted at the VPC level. And if it leaves a data center, either between availability zones, between regions, to your data center through Direct Connect, it's being encrypted again. And so in many cases, we actually encrypt the same piece of data 4 times across our network before it actually gets to the other side. But no data leaves in all the new instances an EC2 instance, even if you do an encryption as well, which we always encourage you to do as well with SSL or TLS. No, leaves an instance, certainly never leaves a data center or availability zone, certainly never crosses the backbone anywhere without having multiple layers of encryption. The other thing about this encryption is it's all quantum safe. And so with the coming possibility of quantum computing, we've got to make sure that somebody's not collecting information now and going to wait 10 or 15 years and have a quantum computer that can actually break it. And so all of our encryption has been upgraded over the last few years to AES 256. That is actually using quantum safe keys. And so we've got to think about what compute is actually coming in the future that could actually affect us. One of the things we did recently, and hopefully some of you have watched this, if you're in the US, this is the other type of football. We've been able to stream something like Thursday Night Live. Amazon Prime won the deal to actually do Thursday Night Football, which is a huge deal in the US. But all of this is actually managed on the AWS backbone and streamed from CloudFront locations. And so all the feeds come in from the games directly into our regions, and then are actually streamed out over our services running on the global network. The thing about live sports is it's absolutely terrifying. You do not get a second chance. It takes the joy out of football for anybody that loves it, but it's incredible to be able to bring live football at this incredible quality and at a latency from the game in real time to your phone or TV screen in something that we've never seen before, getting down to sort of sub-second in many cases. It's really been amazing, and it speaks again to the sort of scale of what we're able to do across AWS, also across Amazon with Prime Video and our global backbone. Let's talk a little bit about our world-class performance. Now, when we started the cloud, we built it very, very simply. In my talk yesterday in a compute keynote, I always joke, we often would bring new college hires in for interviews. And we'd say to them, just design EC2 on the whiteboard quickly. What do you think? And they always got it right. It was actually very simple. We didn't focus a lot on the network performance in the early days. It was all about how do I automate a Zen machine and do distribution plane and things like that. But one of the big challenges, and it actually impacted the network, were high latencies. With a traditional hypervisor, you would actually see about 300 milliseconds at the P99. And that's just an enormous amount of time. That's milliseconds, by the way. I didn't make a mistake, not microseconds of latency. And because of jitter in the hypervisor and all sorts of challenges. And this caused us to completely rethink the way that we do virtualization. It actually started in about 2008. And we used to meet weekly. And the meeting was actually called Jitter, the Jitter meeting. And what we were trying to work out is how do we get network performance to a place where not only is it low, but it's also consistent. And ultimately what we came up with is we had to move all of our networking to offload cards. Those were actually ARM-based. Think of them as smart NICs, but they're a lot smarter than a smart NIC. And we actually built this system called Nitro. And today when you run an EC2 instance, 100% of all of my code, I don't write the code anymore, but my software that runs on the instance to manage the instance for you is actually running on a Nitro code. The network, the storage, the security, the billing, the management, the firewall, all runs on these offload cards running on ARM. 100% of the central CPU, the memory, the storage, everything there is given to you as the customer. We do not use any of that. And that's really helped us to make significant improvements in our performance and our consistency. And we'll take a closer look at the network. These are the Nitro cards. These are the ones that we've used all the way back since 2012. The one on the top left is actually the very, very first Nitro card we used for networking. We're on our 5th generation. We use them for little different things, and some of them are built for storage, and some of them are built for network. The very latest one is actually not shown, but these are the ones you get an idea of what they look like, go into a PCIe slot, and we actually use that to run the rest of the machine. From a networking point of view, you can see the progress we've made in bandwidth. It's really been substantial. We were pretty happy with 1 gigabit when we started. We thought that was revolutionary. But you can see today, we're up to 50 gigabits with our instance launches last year on our 6th generation. In 2019, we had 100 gigabits on our network-optimized instances. And for many time, we were the only cloud provider that had 100 gigabits as well. This year, we've actually announced an instance, which we'll talk about shortly, that goes 200 gigabits per second. And that is the new network optimized. So you could download from S3 at 200 gigabits per second. For our GPU space, we run very large clusters. We get to 400 gigabits. We just launched Trainium, which gets to 800 gigabits, single instance. And we'll be launching Trainium N next year, which is network optimized, and that'll hit 1,600 gigabits. No guessing what we're thinking about next, but we're not going to stop. We're not going to stop moving on performance. As I said just earlier this week, we announced our 6th generation EC2 network optimized instances. So these are Intel Ice Lake-based machines providing you with 200 gigabits of throughput instead of the 100 gigabits that you used to get previously. Now, a super important thing we think a lot about as well are packet per second. Many of you might be running network appliances, and very often it's actually not the throughput that is the problem. It's actually the packet per second. And I'll tell you that on AWS, we've always focused on packets per second. I have teams of people that will take a card and improve packets per second over the lifetime of that card to get to a really good place. We are in the tens of millions of packets per second on these instances. And so hopefully you're not bumping into any packet per second limits. This instance, by the way, is also EBS optimized. So traditionally, you would have had 14 gigabits, 1.4, of throughput to EBS. With this instance, we've now upped that to 80 gigabits of throughput and 350,000 IOPS of performance to your network-attached storage. Hopefully, that's enough as well. We think for most SAN workloads, you should be good. Now, the important thing is that 200 gigabits and that 80 gigabits, completely separate. So you actually have 280 gigabits of throughput, 200 for networking, and 80 for network-attached storage. We also announced our Amazon C7GN instances, and Peter DeSantis spoke about this in his keynote, including the latest Nitro card that we used in these instances. This actually provides the highest network performance out of any of our 7th generation instances, and also gives you significantly higher packets per second than you even get on those 6th generation instances because it's using our latest Nitro card. And so we're very excited about this. Obviously, the move to Graviton is really a huge opportunity to not only get better performance, but to also save significantly on costs. And so some of you might be looking at how do you move to ARM. You might need that network performance, that S3 download. This is available to you now. We launched this on Monday night. Well, no guesses as to what we're talking about next. A long and favorite topic of ours, congestion. And it's kind of built into the TCP protocol, right? TCP has congestion control. It backs off for a random period of time. And when you run TCP within a network and you're really trying to optimize for incredibly low latencies, I'm talking single digit or very low tens of digits of microseconds, you've got to make sure that you have a better control over TCP. And so we actually came up with a brand new protocol about 4 years ago called Scalable Reliable Datagram, or SRD. It's kind of think about it as UDP with a couple of differences. So firstly, it's Ethernet-based. So it builds on top of a standard Ethernet network. It negates the in-order packet delivery that's required by TCP. And the other thing is, we sort of take the actual frame, we break it up, and we actually send it across the network taking multiple paths. So let's take a look at how that works. In a traditional TCP network, what would happen is every flow, every connection that you make is going to hash to a set of routers. And so you can see what's happening here is we've got 2 flows that are running through, and that router in the middle there, let's say these are 2 5-gig flows. And for the purpose of my demonstration, this is not reality. That's a 10-gig router. Now, you've got 2-gig flows starting to hit that 10-gig router, and that router is starting to get a little unhappy. When we add the 3rd flow, well, now that router is completely congested, and you start to get congestion within the network on the router. This is just really hard to manage as a cloud provider, and it's actually one of the reasons why we limit you to a 5 gigabit flow in the network. We've got to make sure that at a router level, we can actually control hotspots and usage. Well, let's look at SRD. So SRD, same thing. We're going to send in 3 flows, and you can see what SRD is doing. It's actually taking those 3 connections, and now we can actually say that every connection is going to hash to a whole bunch of different routers. I don't have to hash to a set of routers across the network anymore. And I can make sure that all of the routers can handle whatever flow size. When we launched when we launched SRD, what we found was we used it for Elastic Fabric Adapter, so we actually got really great performance for HPC type applications. We've also used it for EBS. And today I'm happy to announce ENA Express. ENA Express, what that does is that will provide you with SRD functionality, so scalable, reliable datagram functionality underneath your EC2 instance. Happens magically. So when your instance communicates TCP to another instance in part of VPC, behind the scenes, we've actually enabled SRD using ENA Express, completely transparent. From a performance point of view, first thing, we've increased the flow size from 5 gigabits to 25 gigabits on EC2. So you no longer need to think about multiple connections to get to 100 or 200 gigabits of throughput on your instance. At a flow level, you can now do 25 gigabits per second, which is 5 times what you had previously. There's 50% lower P99 latencies. So at your 99th percentile, which is what we always like to measure, 50% lower latencies just by using SRD. And then 85% lower latencies at the P99.9, which is just incredible to see. A lot of good progress there. Let's talk about building networks. And we'll go through this relatively quickly. But when we launched VPC in 2009, we thought all of you would only need one of them. And we debated it. We're like, who would need more than a single VPC? We even have this thing called the cred store inside EC2, which can store properties and limits and all that sort of thing. And the limit for VPC was actually set to 1. If you wanted more of us, you had to use the telephone API and give us a call. And then we started to get lots of calls. And we realized that customers love building many, many more of these VPCs. And then the problem became, and for many of years, for those of you that have built on AWS, it's been, how the heck do I communicate between these VPCs? And that was the big problem, and everybody at reInvent didn't know what we were going to do about it many years ago. And we launched private cloud peering. That was done back in 2014. We also launched Private Link, where you can actually, you can set up endpoints, and at the web server level, you can share connections. And Private Link has just really taken off. It was a little confusing, I think, at first, because there's nothing really like Private Link in the networking world outside of AWS, but it's really taken off. One of our customers that has been using this has been Autodesk. We've got many ISVs, many customers, and they said Private Link will give their developers an easy, secure, scalable way to enable private connectivity for shared services and microservices. So that's the use case there where within your organization, you have a shared service, you might have many VPCs, and you just put an endpoint, a local private endpoint, into every one of those VPCs. Folks like Snowflake are also using Private Link to share database connections into customers' VPCs. So it's it solves the problem, but didn't quite get there. The next thing we did was we launched Transit Gateway. This was back in 2018, and Transit Gateway has really solved the problem. Today, you can build enterprise-scale networks on AWS using Transit Gateway, bringing together thousands of VPCs, in some cases tens of thousands of VPCs, but also do edge consolidation. So you can bring in VPN and Direct Connect all directly into the Transit Gateway and have all those VPCs have network access and connectivity. Fuse was an early adopter of Transit Gateway, and they actually said that they went from being able to build new networks in weeks, they brought that down to minutes, literally just APIs being able to add new VPCs and be able to scale that. And I think where we are today is we can say, we can actually support you at an enterprise scale. And one of the other things we think about is a decision that you've made in the past shouldn't affect you in the future. And so we want to make sure that you made some decision to create a VPC, maybe at a /18 or whatever the size would be. It shouldn't affect you in the future. And Transit Gateway and all those things have gotten us to a really good place. But there still is one challenge today that most of you have probably never gotten to. Some of you, as you continue to scale your business, you may bump into this. And that's that we can only support 50,000 IP addresses, in-use IP addresses, within a single VPC. And the challenge with that is we've got to think about scale. And this is us actually thinking way ahead of where you are to say, can we make sure we can scale ahead of where our customers are today? And today I'm happy to announce the availability of increased VPC size. And with this feature, we can now support up to 256,000 in-use IP addresses within a single VPC. We can also do 512,000 IP addresses across multiple VPCs when you use peering. And there's, just to be clear, these are in-use addresses, not your size of your CIDR, where you can support many more. These are actually in use. And this is an area we're going to continue to focus on and make sure, even if you've decided, instead of thousands of small VPCs, you've decided to go with fewer very large VPCs, you're not going to bump into some scaling issue at some point in the future. That's actually 3.5 times higher than any other cloud provider today at the 256,000. One of my favorite applications that has really changed the way that we all communicate, and I think most of you would agree and be very familiar with this application, Slack. We've worked very closely with the Slack team on what they've been able to build, which is really one of the world's largest networks, obviously in the communication space. And I'm very happy to welcome to the stage today Milena Talavera, SVP of Engineering and Core Infrastructure at Slack.
Thank you, Dave, and thank you for having me here today. My name is Milena Talavera, and I lead the core infrastructure group at Slack. Today, I want to share our journey from Slack as a startup to a hyperscale company and how we leveraged AWS networking to help us along the way. In recent times, you are probably all familiar with Slack and as the digital HQ that you leverage every day with your colleagues to collaborate, to make work more easy and more delightful. But let's rewind back to the beginning. And so in about 2014, Slack was actually built almost kind of by accident. The founding team was actually working on a gaming startup called Glitch. And they realized they needed a better way to collaborate with each other, and so they built Slack internally for themselves. And they quickly realized that other teams wanted the same product. And so this is how Slack was originally formed. And Slack was born on AWS directly since the beginning. So let's take a look at our journey. So in those days, we created one AWS account. We had a small number of users. There were a small number of services, a small engineering team. And that worked well for us for quite a while. But Slack, fortunately, was a very, very viral product. A lot of people really wanted to use Slack. And so we saw growth up to millions of users globally across the world. We started to increase our engineering team. There's more services that were being built, and we were still leveraging a single AWS account. And that worked for us, for up to millions of users, but we started to encounter some challenges. So we started to come across AWS account limits and rate limits, and so provisioning this much of infrastructure became more challenging for us. And so we knew we had to do something. Also, it was difficult to manage costs and really understand our infrastructure more granularly. So at this point, we decided to subdivide our infrastructure and introduce child accounts. We provisioned child accounts to all the different service owner teams, gave them more ownership. They had VPCs, and everything was starting to scale again in terms of provisioning and our networking architecture. But the downside and the trade-off of this architecture is that there was a lot more operational toil on these service owner teams. They had to manage their IP subnets addresses, typically in spreadsheets. That's probably a familiar concept to a number of you in the room. They had to manage the connectivity between VPCs through peering. And really, there was just a lot more operational overhead on these service owner teams. And so at this point, it wasn't really the traffic scale. It was the operational scale that we needed to reconsider here. And so this is where we started to explore shared VPCs. So shared VPCs allow us to create a VPC in one account and then share it amongst the many child accounts. And we termed that project White Castle. And it's actually a funny story if many of you walked down the Vegas Strip. you may notice that there is a White Castle restaurant on this strip. And so the way this came to be is that several years back at reInvent, at this very conference, the technical leaders that were pondering how are we going to scale our network architecture, they were out late at night still pondering how they're going to do it, and all the restaurants were closed except for White Castle. And so they went to White Castle, continued to work through their design, and named this project White Castle. So great, now we have White Castle, but how do we get our hundreds of other VPCs and child accounts onto it? The Big Bang approach was deemed too risky. That's not something that we wanted to do or consider. And also, rightfully so, the service owners had a healthy dose of caution in terms of moving fast. They're in our service ownership model, the service owner teams are responsible for availability of their services, and so they wanted to be cautious when introducing a new architecture, new dependency. And so this is where the AWS Transit Gateway comes into play. We leveraged AWS Transit Gateway as the connecting point between the legacy non-White Castle VPCs and the new White Castle VPCs so that service owners could move more gradually and connect the two networks. Slack, as I mentioned before, we're a global company with millions of users across the world, and we have presence. We're in a lot of the regions that AWS is present in across the world. And so we're also leveraging the Transit Gateway for inter-region peering as well. I mentioned earlier that when we had the child accounts, that we were managing all these different spreadsheets for subnets and IP assignments. And so recently, a couple months ago, we started to leverage Amazon's VPC IP address manager. And that has helped alleviate and remove the spreadsheets, has enabled us to automate assignments and to monitor and perform retrospectives on our usage of the assignments and for better troubleshooting. So this has additionally helped reduce our operational load when scaling our network architecture. Now, looking back, I'll recap. We've started with a single account. We, at some point, split up and added child accounts. Then we added shared VPCs. Then we added Transit Gateway. And as Dave announced earlier, we are taking advantage of this larger VPC release because now previously when this design was built, that was definitely one of our concerns. Is a VPC going to be able to be big enough to support the number of IP addresses we need in the future? Are we going to have to evolve our architecture again? So we're definitely very delighted to hear this release and looking forward to the partnership along the way. One of the lessons and takeaways for us has been a couple. One of them was definitely our partnership with AWS. The Transit Gateway, the auto-scaling capability was super important to us, and but also we had to work closely with our AWS team to make sure that there's sufficient capacity to handle spikes of load for the Transit Gateway because it became the critical traffic hub for our network. And so, we stubbed our toes a couple times here and there, but our partnership together with Amazon ensured that we can support all the traffic that we need for Slack's growth. And additionally, migration, it's super important to have a migration plan because we can have this shiny new architecture, but if we don't plan for how we're actually going to do the migration, how we're going to make it easier for our service owners, then it just doesn't happen. So thank you so much for walking on this scale journey with Slack today, and now back to you, Dave.
Well, thank you, Milena. That has been an amazing journey. I'm also an avid Slack user as well, as is everybody at AWS, and so it's been a really, really good partnership. It's just amazing how much data they carry across that Slack network. Well, let's continue our journey. Let's talk a little bit about networking for applications. And I hinted a little bit of this at the start, is that we really have these two personas that we kind of got a little muddled up in the cloud over the years. And the network administrator, from a connectivity point of view, they want stricter control to ensure that only approved entities are communicating on the network. The developer just wants to connect their applications without having to worry about VPCs or IP addresses or peering or private links. They don't have to worry about the networking side. From a security side, the administrator wants to be able to enforce proper identity and authentication and do that consistently across all of the compute platforms. A developer, again, just wants to be able to use the right compute platform for their workload and also have the right integrated support for identity and authentication. Again, it's not something that you should be part of every single delivery that they actually go and do. From a visibility point of view, the administrator wants full control and visibility into the network and ability to monitor and audit all the traffic flows. And a developer just wants application logs, and they're not overly concerned with all the things that are being collected behind the scenes. And we've had things like VPC peering over the years, or shared subnets, which has allowed you to have an administrative team own an account and then share these subnets across with developers, where developers don't have to worry about the VPC or the security group or the internet gateway or the NAT gateway or any of those things. And one of the things that's been done in the past is this idea of mesh networks or service meshes. And a service mesh is a platform layer that enables sort of managed, observable, and secure communication between individual services. And the idea was, let's abstract away the network complexities from the developer and just allow them to use service discovery and actually have the applications be able to communicate, run the right encryption, run the right authentication. But service mesh, the design, came with a few challenges as well. It wasn't natively supported by AWS and required you to run sidecar proxies. And so this were really sort of little agents and proxies that existed within your instance. You had to make sure that they continue to run. It was also very, very bound to containers. And while we all love containers, there are many workloads outside of the container space that would also benefit from this type of mesh networking. And it still requires some networking expertise. Because the actual sidecar runs inside the instance, very often that's the developer's area, and they have to worry about the sidecar and think about the network and how that's set up. And so this is a challenge that we looked at several years ago. And we said, how could we make this better for developers and network administrators on AWS? And so today I'm very happy to announce the availability of Amazon VPC Lattice. VPC Lattice allows you to basically set up what we call a service network within any VPC, no matter what network topology you have today. It's natively integrated, doesn't require any sidecar to actually manage that, all natively built into Nitro, natively built into the VPC protocols. It also works across all workloads. You can integrate with Amazon EC2 instances, integrate with EKS, ECS, and Lambda. So it doesn't matter what compute platform your teams decide to use, they can now decide to expose those endpoints as part of the mesh and have them discoverable by any other service that's actually using that mesh to communicate. There's no networking expertise required. If this mesh happens to, the service network happens to span VPCs, and those VPCs aren't paired together, the fact that the mesh spans those VPCs, AWS will take care of the complexity of actually sending those packets between those VPCs. They will be securely transferred between the VPCs. The other one is you have traffic and access controls. And so we made very sure that this product does not hide anything from the network administrator. As a network administrator, you can still use all of the tools and services, things like security groups, transit gateways, you can still see flow logs, you can still see traffic mirroring. Any feature that we have in the underlying network continues to work. So let's take a look at how this would work. A network administrator would go in, and they would actually create a service network. This is something that would exist inside a VPC. They would have subnets within that security network, and they would share those subnets with the developers. At this point, the administrator can do what they like on that account from a network point of view, and developers never have to think about the actual VPC or the underlying network. Developer would come along, and they would build their applications and services using EC2, EKS, ECS, or Lambda within that service network. And now they can automatically, without ever having to see an IP address, actually communicate between those instances. We'll do things like authentication, other sort of network controls and protocols behind the scenes as part of the service network. So we're very excited about VPC Lattice and excited to what you see and think about it. It's in preview at the moment, so go and get access and start kicking the tires. Next thing we want to talk about is observability. You know, this has been one of the things we've thought about a long time in the cloud, is often customers would tell us, I'd love to be able to see more. When I use the cloud, I feel like there's things behind the scenes that I don't have visibility into. And over the years, we've been working very hard to give you visibility into things like contracting and packet per second limits. And there's actually metrics available in AWS today. Even though it's the cloud, and some that might disappoint some of you, those things are still a reality. We try and make sure that you never bump into a contracting table limit or you never bump into packets per second, but we do want to give you visibility into that as well. One of the things we've been trying to do for a while is actually provide you with a way where you have a single pane of glass that provides you with visibility into all of the various metrics across the system. And today we're happy to announce that our AWS Network Manager is now available and provides you with detailed monitoring into all of your networking infrastructure. It also includes an infrastructure platform that provides you with details on like network latency and other things that you're able to go into and have a single pane of glass to think about the monitoring of all of that. We spoke about it a little bit earlier, and that was what we call internet weather. Every now and then, you might have an ISP out there somewhere on the internet that actually has some sort of problem. It's incredibly hard to debug. In many cases, actually, you resort to Twitter, trying to see if anybody else reported a problem with the ISP. But there's not really a tool that can bring all that together and give you the information you need. And so what we wanted to be able to do is to understand how internet weather events affect your application. And often, as I said, that can be very, very challenging. We wanted to simplify this, though, given the scale of our backbone and the information that we have on pretty much every single ISP in the world, and be able to give that information to you. And today, we're happy to announce the availability of Amazon CloudWatch Internet Monitor that actually provides you with detailed information on what's happening on the internet. And with this monitor, CloudWatch Internet Monitor, we're able to detect internet weather events, which we already do today. We're able to diagnose them, and we're actually able to have insights into these weather events that are specifically tailored to things that might affect your application. So if you're using receiving traffic from certain parts of the world, or customers on certain eyeball networks, or customers being routed through other networks before they get to AWS, we're able to show that to you. And so that when you do see a problem or you get reports from customers in some geographical area, you can go and check the CloudWatch Internet Monitor and actually say, is AWS showing us something that we should be aware of? It also supports alarming, so you can actually set up CloudWatch alarms. And so if there's large internet weather events that are affecting your application and you maybe need to take action, you can actually get that level of insight now with the CloudWatch Internet Monitor. A few screenshots. You can see the monitor example here of how we're picking up latencies and health scores across different ISPs. We'll also actually provide you with a map of the world, and so you can actually see internet weather events at certain places in the world as well. We think this is going to be incredibly useful in just broadening your visibility into things in the network out there that could be affecting your application. Let's look a little bit at security. Security has always been our #1 focus, and it still is today. I spend an enormous amount of time on security every single week. Just making sure, firstly, all of our software is up to date and deployed well, our networks are secure. We just have meetings about that, constantly staying paranoid in the space to ensure that we can always be a leader in the security space. We have a number of things, including compliance. We have a lot of industry certifications, and then obviously world-class performance in the security space. When you look at a VPC today, and I think this is one of the reasons why you all didn't just have one of them, they are these really nice little secure networks that you can isolate from everything and run an application in there. In some places, you might give it a NAT gateway. But we've got a number of tools across AWS that allow you to ensure that things are secure. The very first one we had all the way back in 2006 was the security group. Kind of like a firewall you can attach to any instance. But you can use NAT gateways today, the network firewall service that launched just 2 years ago, fully managed firewalls. Partner appliances, we'll talk more about that. Obviously, encryption. You've got the WAF, AWS WAF, DNS firewall now as well. You can actually firewall off DNS names going out of a NAT gateway. And then AWS Shield. And so we haven't spoken a lot about DDoS and that sort of thing, but I can tell you that when you're running on AWS, we're mitigating those DDoS attacks for you. We're doing them every single second of every single day at scale, and they're not affecting your applications. AWS Shield, you can also get DDoS support if you go for Shield Advanced, where we'll actually work with you if you have a large event coming up and you're worried about the risk of a DDoS to make sure that your application's ready and scaled. Many of you might be coming from on-premise networks, where you're already using appliances that you know and love, and you want to be able to run those appliances in AWS. And one of the things we've focused on heavily over the years has been how do we bring those appliances to you? If you remember the AWS Marketplace, actually the largest section in the Marketplace today is the network and security section. But in the past, it's been pretty challenging to take that, whether it's a Palo Alto firewall or a Cisco router or whatever you might be using, and actually bring that into your VPC and then ensure that it's highly available and scalable. And that's something that I think is largely a solved problem today with the way that Transit Gateway allows you to bring those appliances into your VPC and intercept traffic. So you could say, put this appliance in front of any traffic. You can also do that with Internet Gateway and ingress routing. So you could put a firewall in place today, and you could actually route all traffic through that firewall, regardless of the actual destination IP address. We've also done that with east to west traffic now, so traffic between subnets. You can put firewalls or any of these appliances in that location just seamlessly with VPC routing. And then we launched the Gateway Load Balancer last year at reInvent as well. And Gateway Load Balancer actually operates at layer 3 and does a whole lot of fancy routing and hashing to ensure that you can take these appliances and actually scale them horizontally. And so in many cases, the actual vendor would tell you you can run no more than 4 of these next to each other. But what the Gateway Load Balancer does is each one operates completely independently, and we manage the network routing so that you could literally run hundreds of these and get to 100 gigabits of firewall capability. And if any one fails, it'll only affect flows that are currently flowing through that. We'll automatically rehash in a way that doesn't interrupt any of the other ones. So it's become an enormously successful feature and a way to take all of these appliances, and there's many, many more, which couldn't fit them on the slide, and actually run them in a highly available, highly scalable way in the cloud. If you don't want to manage the appliance, we have the AWS Network Firewall as well, which is obviously highly available, flexible protection, continuously adding new features there, and real-time monitoring. Now, in the security space, one of the things that changed for a lot of us is we all started working outside of the office in the last 2 years. Well, obviously with COVID and the pandemic, we were forced to do that. And many of you would wake up every single morning and you would have, the first thing you did was log into VPN. And you spent the day on VPN to make sure that you had access to the network. Well, at Amazon, we started to change things. We started to implement what is called Zero Trust. And so while at the start of COVID, we were all still logging in to get our email and to get access to the phone tool and whatever else we needed, by the end of COVID, we've never needed VPN anymore. It's very seldom that I actually VPN into the Amazon network. And actually at reInvent this year, it's the very first year that we haven't had the Wi-Fi network called WPA2, which is the default network for all Amazon employees. And most of the folks that are here, when I've mentioned that to them, they haven't even realized it's not available because we just log into the same reInvent network that you use, and Zero Trust means that I can get to all of my internal Amazon tools, even my email, without having to worry about whether the network's trusted. And so the idea with Zero Trust is that things are actually shifted to not trusting the network, but actually trusting the authentication at an application level. So the idea is, I don't have a trusted network that you've authenticated with through VPN, but just put it on the internet and actually trust it at the application level. And I'm happy to announce today the availability of a new service called AWS Verified Access. And AWS Verified Access is a service that allows you to essentially bring Zero Trust networking to your applications and start to move your applications away from VPC. And so essentially think of it as almost like a load balancer or proxy that you'd put in front of your application. It will automatically integrate with IDPs and other services that you have to make sure that you can make it highly available and not require VPN, but authenticate at the network level. So from a cloud deployment point of view, what did you typically do today if you wanted to run Zero Trust? You would actually set up a network, you'd set up a whole lot of applications, and then you'd have to think about, well, I need a VPN policy. I need some way of bringing that in. I would need an IDP, some way of doing authentication, and I'd need some sort of device policy as well to ensure that I'm managing my end devices. A lot of work to do in bringing all of that together. With AWS Verified Access, you can actually improve the security posture. because now it evaluates each user request in real time as it comes into that service. There's no longer a need for VPN or any of those other services. It simplifies operations. We can onboard applications using just a few clicks. You can literally create a verified access environment, and as you bring new applications in, they're already configured with the policies and setup and systems you've done for your IDP that you might be using. It also has increased mobility, so users can be anywhere in the world. They can use different devices as well. They no longer need to be on something that's actually VPN'd in. So let's take a look at how this works. The same environment, and now you create a new AWS Verified Access endpoint for your application. You integrate that with trusted providers. These are third-party providers that you might already be using. IDP, EDM, others can be part of the authentication pipeline. And now request, there's no need for any policies, any management, anything else. It's all managed by AWS, and all of those applications are available from wherever you might be in the world, whatever network you might be. As we think about the providers and access partners, we have a number here that you're probably already using, folks like CrowdStrike and Okta and Ping. And on the observability side, Datadog, IBM, Sumo Logic, well-known partners that have all integrated directly with AWS Verified Access to ensure that we can simplify the process of moving to a zero-trust world and having authentication built directly into the network. The other thing we've done with this service is we've disrupted the way that these services are priced. Typically, how you price for these is you price by user. Challenge with that, it's not cost following. And secondly, it means if you have many, many users in your organization that need access to the phone tool, that phone tool is pretty expensive. What we've done is we price by application endpoint. And so you can start small, move one application, pay per hour and through the data transfer for that application endpoint, add applications over time. Doesn't matter how many users you have actually accessing the services. So we think that's really going to change the way that we think about zero trust. Let's move on to our last section and talk about building networks at a global scale. Certainly started off in that looking at our backbone, but one of the things we've seen with customers is the journey that they take is you start with a data center. Some of you might still have data centers out there. And then you have to think about, well, I have all these campuses and branch offices and corporate offices, and I have manufacturing facilities, and they all have to be connected. And so all those blue lines are very often MPLS connections that you've had to put in place, or fiber you've had to secure from third parties. Well, you introduced the cloud into this network, and what happened is now you've got a connection to the cloud, and on the other side, you've got a whole lot of users that might be accessing the cloud from various locations, and it's become a key part of your network. But the cloud is you're still running all these separate networks and having to worry about them. And that actually pulls you in a whole lot of different directions, because you have to think about, well, this is my MPLS network or my branch network, or how am I solving this? Maybe you're using SD-WAN in some areas. And that can be really, really challenging because the management and complexity that environment brings can make it challenging. And so we've been looking at how we would make this simpler for you. Was there something that AWS could do, given the scale of our backbone and all of our edge locations, to actually say, hey, you could use more of that backbone for your full network? And last year at reInvent, in Werner's session, we actually announced AWS Cloud WAN. And so it's been available in GA now for about 6 months. AWS Cloud WAN is a super simple network that allows you basically to bring all of your on-premise networks, whether they're branch offices, data centers, whatever it might be, actually onto the AWS backbone. And you can do traffic today that actually goes from a branch office to another branch office over the AWS backbone, and it never ever terminates in an AWS region or local zone. And so it really is end-to-end. You can come in from Direct Connect, you can go out via VPN or Direct Connect to a different location. Obviously, it's all secure, given it's on our backbone, and we also provide you with visualization and monitoring of your global network. We'll actually show you insights and visibility even into your on-premise applications. Let's take a look at how this works. So we started off with our data center that was connected to the cloud. What you would now do is you'd go and define AWS Cloud WAN. And you'd bring that in. And basically, you have all of your stuff that traditionally used MPLS and was connected to each other and managed that, even via SD-WAN. You would bring that in directly into AWS Cloud WAN. You create a new Cloud WAN object within AWS. Cloud WAN is actually built on top of TGW. So all the performance and benefits that you get from TGW and inter-region peering, it also uses Direct Connect behind the scenes. You'll get all of that available in a fully managed environment for AWS Cloud WAN. It also has the capability of doing network segmentation. And so if you have different segments. It could be sales, it could be developers, it could be testing and production, whatever it might be, and how you want to manage those network flows and keep them separate for the security or availability. It's all built directly into AWS Cloud WAN. We've had a number of customers adopt Cloud WAN over the last year, and it's been really great to see the progress that they've done. And so this customer, which is Foundation Medicine, said we use AWS Cloud WAN to simplify connections between our globally distributed labs and cloud resources. It improves the secure collaboration between the departments and sites at a global scale without incurring manual overhead. We had one customer that said it literally used to take them many, many months to bring a new branch office up, and now it was just an API call because there's no deployed infrastructure anymore. It's all available. You can get it set up immediately with a few API calls. And so it really, really has changed the game. So I encourage you, if you're looking at ways to simplify your network, consider AWS Cloud WAN. Well, it's been a fantastic journey. I've thoroughly enjoyed it, as I always do, talking about networking and all the innovations and enhancements. I hope you have some time to look at the new features and go and see how they work and have a look at them on AWS. We have a number of networking tracks at AWS this year. Each one of them goes into a lot of detail, and so I encourage you to find those. We started out with this little guy. They thought he was a rocket ship, and we spoke a little bit about our vision to be able to give you a highly scalable network that can support any workload that you bring to us and really drive innovation. We don't want it to get in the way. We want it to be something that just works and also support you if you're a network administrator or if you're a developer. One of the things I want to encourage us with is we've achieved a lot over the last 15 years, and I think many of you have achieved that as well in your organizations. But let's never allow ourselves to be comfortable with where we are, because really, we're all just still getting started. Thank you very much.